We'll have a, again, we'll continue with the numericals related to all these 4 chapters. Yesterday you had that exam, no? It was, I think, not good paper. Huh? I have seen almost a lot of LCT exam questions were there. It was not like almost like a full paper. And the questions also like directly from material, it seems, level 1. Not well balanced paper. That much I say. So any doubts, no, you can just clarify. So 2 to 3, I'll be available. No point of discussion. I'll just post the question paper, and if you have any doubts, no, you can just call me. I'll be there in Zoom. That particular question, I'll explain it. That one. So I don't think so. You have to put any effort on that paper. It is of that kind. Okay, we'll continue with the numericals. Okay, read the question. All small numericals I just picked up. May not be very lengthy all these. Okay, we'll begin like this. Huh? Okay, read the question. So it's skateboard. Okay, or like in our books open, it'll be like a trolley moving down. A particle is projected from the trolley, so that again you will catch the ball. Let's see that thing. So is a okay. It throws a ball so that he catches it back after time t. What velocity was the ball thrown by the ball is relative to himself. That one. Again, after some time, it will be available here. So what should be the speed of projection? I think if we project the ball with a speed VR perpendicular to trolley, no, then what will happen is going to receive it. So here, by the time it arrives here, it will have velocity, say V2. So in the trolley frame, how the motion of the ball will be? In the trolley frame, the motion of the ball will be the person will not be at the position of trolley will not be at same point. So in the trolley frame, this will be the condition. With respect to trolley, I should show, not with respect to incline. Then on the ground, with respect to ground, what happened? It'll be like this. So how the so what is the value here? So it should be theta. So how much it is g sine g cos theta. Time of flight is given. So therefore this will be with the speed with which I'll throw it minus u. Okay, this is ur minus ur minus g cos theta into t. So this will be 2ur by g cos theta. Is asking that speed. So ur will be gt cos theta by 2. Himself he has given time period. So I should project with this much of speed normal to the trolley, perpendicular to the trolley. Then in the trolley frame, the person on the trolley says it is just ascending and descending. What will be the path with respect to ground frame? Because of acceleration g sine theta, how it will move? It is going to move in a parabolic path. Okay, path with respect to ground, there's a path. I think we had many problems, the discussion of like this. simple idea base can be dumped in advance. You have to be very even in mains also they can ask you because no idea, nothing is there, no calculation, nothing. You do have some very good questions related to this. Suppose if this day trolley moving on the ground, it is moving with a constant velocity. Let Vt be the velocity of the trolley. I'll drop a ball. Then how the motion of the ball, let h be the height of this trolley. How the motion of the ball, it is moving with a constant speed Vt. So in the trolley frame, this person, what he says, there are two persons are there. Okay, there's a point, will mark these points. P1, okay, so some other, this one. So this person, what you will comment, what will be the comment from this person? The ball will strike at point P1. No, it is just above P1 at t equals 0, the ball will be dropped. After some time, what do we expect? The ball will be there only, no? Oh, so the ball will move vertically down with respect to ground. I think I'll give the diagram here. It'll be easy for me here. Yeah. After some time, we expect the trolley will be in some other position. So let it be here. Where the ball, so the ball will strike like this. So this was the point P1. No. So what this person will say is how the ball moves vertically down. What will be the comment from this person? What will be its comment? Ball moves in parabolic path. Okay, simple idea. Already you might know this. Please do revise this one. Like a ball dropped in a moving trolley, ball projected in accelerating trolley, from the trolley, ball projected. I think we have discussed many numerical. Just go through once. For exam, I think objective rather than asking something numerical, no, they may ask you something like how the path of the ball will be, how the trajectory will be. Ball moves in parabolic path with respect to trolley, no. With respect to ground, it will be vertical. Here I took different here, the cases. Here the question is, you will catch the ball again there only. For that purpose, Altman, with respect to ball, it will be ascending and descending, normal to incline. With respect to ground, parabolic. I think you can't just say that everything will be same. I think it all depends upon the situation, what is given for us. Are able to analyze the condition here. So you can't make this a generalizer. It all depends upon the situation is what. I just brought two things in here in the trolley frame, ascending, descending, ground frame, parabolic. Here what will happen in the ground frame, it will be just vertically down. In the trolley frame will be parabolic. So based on situation, what happened, we have to conclude here. Not like you can't generalize every problem. Okay, it will happen. Agreed? Okay, read this one. The spider is somewhere here. And there's an insect. Okay, there's a velocity of the belt. Paper, huh? Okay, velocity of paper will write it. Okay, the spider, it is a test. It will not move. I think you read question. You read question. I picked up all problems where you have to understand question, and within 2-3 lines you can solve. You can end up the answer. This everything is the paper. Huh? Okay, the paper is moving with a velocity. Huh? So find the speed of ant relative to paper so that it will directly what happened will be enjoyed by the spider. Okay, how it should move. So it's a, like a, shall I put in simple way? It's a riverboat concept. Okay, if it moves with the velocity of ant with respect to paper. Okay, let it be this angle theta. I'll take this angle theta. It'll be easy to indicate. So here velocity of paper will come, so that velocity of ant with respect to ground will be in this direction. So it has started from A, it has to reach B. You ask ant where you are heading. You'd say that I'll reach C and I'll be safe. But final open, it will land into the mouth of the spider. The same riverboat concept it is. That one is asking find the speed of ant relative to paper. What is asking VAP? Okay, what we have, the ant, the spider without moving itself was able to grab the ant 5 seconds after it started. So we know it will start from here. Problem is very simple. It's all, and it will finally, it will end up here. So what is the time taken by the ant to move from A to B in the ground frame? In the ground frame. So velocity of ant so should be equal to W by T. No? So W is how much? 10 and it is 5. So 2 centimeters per second. Okay, then let's get into the formula. VAP equal to VAP bar minus VP bar. So velocity of ant with respect to this one. The triangle. Speed of the ant, no? Is asking speed. So speed of the ant with respect to this will be 2 square plus 2 square root 8 2 root 2 centimeter per second. Is that okay? No, the speed of the ant with respect to paper, and so that was the condition given for us. It will reach here, this one. So at what angle theta it should move? Theta must be 45 degrees. Not 45. I'll bring it. Tan theta will be VA by VP. VA is 2 by 2. 45 degrees it will come. If it moves at an angle 45 degree with this much of speed, it will land here. But since it's given, it will be eaten by the spider. So therefore I assumed it here. If it moves at some other angle, no, so then it may land here. Or so like if I change the angle theta, what happen? It may not land at B. problem is simple. Riverboat concept is what should be applied here. So one information what we have is like a time taken to move from A to B is available. In the ground frame, I'm able to calculate the speed of ant. So this will be the path of the ant with respect to ground. You ask ant with respect to paper, it is moving like this. After some time, what happened? This particular point will land here. The paper will be moving here. The points itself will be available here. I think you should not think much. That's what I feel. Simple. Take the next one. Initially, block is here. Okay, no, the situation. After some time, what happened? The block has to block B, no? This is block B. This is A. So by the time when the block reaches here, what is the time taken for it? So how this is moved? This is moved horizontally. So how do you expect the rope? It should be like this, or some other thing, because the block B, the block is moved horizontally. So let it be somewhere here. And this I'll put red color only so that. Okay, we know speed. We know speed. And he has given this length of the rope, 12 meters. This we know length of the rope 12 meters. This is 30 degrees. What can be this height? 6 meters. In this is 2 meters. If this is 2 meters, this will be 4 meters. So what can be length of this part of the rope? Should be 16 meters. If this is 16 meters, this is 4 meters. Okay, what can be this distance? This should be equal to U into T. So let's get into 16 square is equal to 4 square plus UT square. No need of constraint also. That condition has to be assumed clearly. We know U, so we'll just calculate the time. Anybody value? 256 minus 16. Anybody value time?
Root 240.
Root 240 by speed is how much? 1 meter. Only this much. Root 240. Square is there, no? Even 1 meter square. All are in centimeter. No? Yeah. Nothing to do. Very simple idea. This position versus 1 by V graph. Find the time taken by the particle to move from x equal to 3 to x equal to 15 meters. this is that curve. This is that curve. The red color one is what? Experimental color. I think now it's visible clearly. Okay, we'll do one thing. We'll write equation for the find the time taken. Let me check it. Let me check the value. So this will be x is equal to what is the slope? Slope will be positive, no? So 15 minus 3 by 8 minus 2 1 by v plus intercept. Anybody intercept? Intercept I think should come negative. Yeah, will be negative. Check it once. Anybody value of intercept?
-1.
Minus 1. So then everything will become 15 minus 3, 12, 12 by 2 by v minus 1. So we know v equal to dx by dt. So let me differentiate this. It's asking time, no? Okay, I should replace this one. X equal to 2 dx by dt minus 1 or x equal to 2 dt by dx okay, integrate this. So it should be 3 to 15 0 to t. Anybody value t? 60 seconds given us, check once.
60 only, sir.
60 only, yeah? Yeah. So now I think you do one thing. We have discussed some, especially in kinematics, what all student should go for this one? ST graph, BT graph. I think there's a normal, then VS graph, then AT graph, AS graph, then AV graph. Then we have all other things we have brought it. So many other, many graphs we have brought it like SS, this is 1 by V graph. Okay, then V 1 by S graph. So there are so many things are there. Check it. I think I'm unable to recollect. 1 by S T graph, then TV graph, VT graph, TV graph. First one will be y-axis, second will be x-axis here. This will be y-axis, this will be x-axis. So like this, we have plenty, I think around easily 15 types of graphs will come. You must go through once before going for mains advanced. I think you look at kinematics, no? What is very important, especially the mains exam, very important is the graphs motion in one dimension. That is what, rest of everything you can manage in exam, whatever let them ask. Then in advanced, what will happen? He can ask you anywhere, but the graphical things given more weightage. You can say almost it is coming to 40% of total questions till now they've asked. Uniform accelerated motion along with graphs. Rest all everything kinematics 60% is there. So definitely I think there's a one very important topic. So go through all the graphs. So what actually graph will have only two things, no? Area under the curve, slope. What information I'll get from area and the slope. The only thing is what we have to search for it. In different types of graphs, area and the slope. What is the use of that? I think those are things what you can calculate from the graph. So what is the use of slope? What is the area under the curve? What quantity it can represent? Then proceed here. So here, sir, like you didn't took area or nor you took any slope. Worst case, write equation and solve it. I think the three parameters will come. One, area under the curve, information of the slope, or write equation. Then proceed what information you can gather from that particular equation, solving that. Hmm? Please go through, very important. I think I discussed some several good graphs are there. It's available. You can revise one's notes. I think the effect of weight will be act perpendicular to plane of paper. G will be acting perpendicular to plane of paper. This is the, okay, the role of G will not come into picture. I can't draw exact, so maximum will try to explain through one diagram only. Plenty of diagrams not possible. Huh? Okay, let me take, this is the center, four lines. Yeah. There's a thing. So it is rolled with a velocity. You look at that velocity here. With respect to wagon, I think problem has become very simple. So the ball will be rolled here. So you write it. At the same time, it will accelerate. So let's discuss the motion of the person standing on the platform. So because of horizontal velocity and acceleration, what do you expect? A parabolic path, you know, projectile motion. And this telling it will pass through the center. So how the path pass should be parabolic. Any reason for that? Because of this acceleration, u1 will remain same. Its velocity component will keep on increase. At one point, it will be like this. So at this particular, when the ball has reached here, now it will start undergoing retardation. Now it will start undergoing retardation. What actually, I think we are just discussing in, better to discuss the problem in trolley frame only. Don't jump to ground frame. Very difficult to justify things. So after reaching here, the path, I'll remove this. So where the ball now? So the ball will be here and it starts moving in a, it will undergo retardation. So put A like this. What should happen to this one now? How do it will continue to move? What will happen to that horizontal component of the ball? It has to remain same, no, everywhere. Even when ball is here, and it will acquire some velocity along this direction also. Vry, okay, there's urx, I'll write it. Now what will happen? It is having that Vry and Vrx, where this everything is equal to Vrx only. Let me write. Now it will undergo retardation. So then what is the path of the ball? Again it will be a parabola, and it will be like this. So how do we can say all these things? So how the velocity of the ball will be known? It will have only which component? Same Vrx. And it will strike exactly at this particular point. So he's asking C, no? Himself, he has given all the conditions. So therefore I should assume like this. Will the ball hit wall BC or wall CD or the corner C? It is going to strike the corner C. First one, ball. Next part. What is the speed of the ball relative to wagon at the instant it hits a wall? What should be the speed with which it will strike? Again, it should be U only. Yeah. In the ground frame, what actually happens? In the ground frame, what actually happens? Anybody, can you tell how the motion of the ball will be? I think better we have to draw the diagram. So the train will not be there only. Yeah? And this is what given velocity UR. So even in the ground frame, will it strike point C? Okay, a person standing in the trolley says it strikes it. In the ground frame, the particular black color box will have a displacement here. Will the path of the ball, will it be parabolic in the ground frame? I'm able to make problem very simple. Himself has said that it will be at the center the moment it starts applying brakes. Therefore, I'm able to conclude here. Otherwise, it will be very difficult mathematically. Anybody ground frame?
Straight line.
I think we'll try to. We'll draw small boxes. So we'll see what actually is going to take place. After some time, it will be here. After some time, it will be here. The ball initially started like this. And this is what? A, B, C, D. At t equals 0, this is a situation. After some time t is what? We have this condition. How the motion of the ball will be. What is the effect of acceleration here? So actually we'll be projecting the ball with a velocity in this direction. With respect to ground, the velocity of ball will be somewhere like this. Is that okay? The dotted line is very important, path of the ball.
So it should accelerate downwards now, sir.
Which one?
Wagon.
Not accelerating. Say initially it will accelerate, then afterwards retard.
It should be downward now, sir.
Which one?
Acceleration initially. Afterwards, it should be upward. Else it's not possible.
Why?
Wagon's frame, the acceleration on the of the particle will be upward now, sir. Which means the acceleration of the wagon should be downward.
Sir, he gave acceleration parallel to dA, sir. So it will be downwards only.
To be at center, the reference
The ball is rolled along with a velocity. The ball passes to the center of wagon, upright, and begins to retard. That is equal to a ball is given velocity parallel to AB. No, it is.
But wagon is given acceleration parallel to dA, sir, not AD.
Along that wall only, no, it is.
Yes, sir, but acceleration should be downwards. Or else this motion is not possible.
In the fourth line, he gave, sir, the train is moving with uniform acceleration in the direction parallel to dA.
Along that side, no, it should be okay. We'll do one thing. This is the if it is downward. If it is downward, then what means pseudo force will act like this, huh?
Yes, sir. So it will be upward.
Upward and all. Oh. In the train frame, no. In the train frame, it should be. Then it should be. Okay, this is t equal to 0.
Yes, sir.
I think here I'll change direction. Okay, that's one. In the trolley frame, no, pseudo force should act on it. This is t equals 0. The ball is projected here. And I'll take it all these diagrams. May not be. Where is the ball is here, no? Then it should strike the C. Okay, this will be correct, no? So now the velocity of the ball with respect to trolley frame should be directed like this, huh? Straight line. Yeah, okay. Can be asked either in matching or any other thing. No calculations. Path of the ball. Okay, now we'll take some problems where some calculations are involved. Based on the inclined projectile, little bit. Okay, in two frames, you can solve this problem. In the wedge frame, so in the wedge frame, how the motion of the, in ground frame, the ball just will move vertically, will ascend, then descend. When during descending, it will strike it. If you stand on the wedge and you see how the motion of that ball will be. So there's the velocity of ball with respect to ground. So you do one thing, just have a basic idea what actually goes on in this numerical, what actually goes on. So here we'll have some small rough diagram so that it'll be useful for us in the writing equation. So the ball will be time based. Okay, I think I can give diagram up to only this particular thing. Initially, the wedge will be here. At t equals 0, it is projected. Uy, I'll write it. There's a ball. When it is striking, what happens? The wedge will be at this particular position. I think I can't give diagrams better than this. Okay, this is the wedge. You can solve problem. So better let's analyze in both the frames. You'll be in a better position. Huh? Okay, the wedge what will happen when it is reach the ground. No, so when it is at certain position at some time, the ball will strike it. This is at t equals 0. This is at time. And the wedge will be moving with a constant velocity. That is u. That's what the overall problem is. In the ground frame, how the ball will appear? The ball will appear just ascending, then descending. While descending, it will strike certain point on the wedge. In the wedge frame, how do it appear? So for that, what happen? Let's get the velocity of the ball with respect to wedge. So what we should do for that? Go back to velocity of ball with respect to wedge equal to velocity of ball minus velocity of wedge. How the velocity of ball with respect to wedge is what needed for us. What is velocity of ball at any instant of time? Or at t equals 0, we'll see first. Later on, we'll make a decision. At an instant of time, what will be the thing? So at initial, I think, let me do initial velocity of ball is how much? It will be v. Just wait, I'll send my kit. Now this will be 20 j cap. Velocity of wedge will be minus of plus 20 j cap minus of what is the velocity of wedge? Anyway, it is 10 I cap. So how do it will be? 20 10 I cap. I think this is very important. Once you can get this, it'll be easy for you now. This is at t equal to 0. At t equals 0, person standing on the ground, he says that ball is projected vertically. A person standing on the wedge, what he'll say that it is projected at an angle. Oh, able to get this one. So this will be the UBW. I'll write it. This is theta. Or this is you write in short. UR speed of the ball with respect to wedge. So this will be URX. This is URY. And then how would it move? It is going to move in a parabolic path. As we said that it is going to move in a parabolic path. So therefore, now the trajectory will be like this. Then what is telling? The particles strike the inclined BC normally.
I didn't say relative flame.
Which relative flame?
Like relative to the wedge, it strikes normally. In the ground frame, it cannot strike normally. No.
No. While it was falling in the wedge frame only, it should be the particle strike the inclined BC. Inclined BC means I think it is understood with respect to wedge only. This is VR. I'll write it. With respect to wedge, it will be striking because in ground frame. That's why I made in the beginning only clearly. I said that it will ascend and descend in the ground frame. In the wedge frame only, it will strike normally. Or I'll add sentence, what is there? While it is falling with respect to wedge. Okay, fine.
Sir.
Particle strikes. Huh? We'll add that sentence. Okay, it will be very easy for us. Okay, I think this much. Okay, what we have to do now? What are things? Find the distance AB at the instant the particle was projected from A. T equals 0, it is here. After some time, t will be here. In this diagram, this is t equals 0. Here, it will be t equal to 0. This is the time. It will strike normally. It will strike normally means what do we expect this angle? This angle is 45 degree. This angle also should be 45. I should not draw curve, no? It should be. So it will be VRX and VRY. So both the components must be equal. So here I'll write it. VRX should be equal to VRY. What will happen to horizontal component? Because the acceleration due to gravity will be acting vertically down. So therefore, this should be equal to how much it is? VRX equal to, and in fact, VRS equal to URX. And VRX equal to VRY. The reason for that at the point of striking. This initial part is very important. Once you are able to make a guess of this, rest all calculations very, very easy at the point of striking. So do we know URX? URX is 10. So do we know VRY? Yes, we know VRY. Therefore, do we know URY? URY is what? 20 meter per second. Am I right? Can we calculate the time? Minus VRY equal to URY minus GT. So this is minus 20 plus 10 minus, okay, this will be T. 1/3 seconds.
3 seconds.
Sorry, 3 seconds. There's a time. After this much of time, it will go and strike the the wedge. Okay, there's a moving wedge. But for the particle, how do it appear? Shall I think I'll not say there's a wedge itself. I'll just keep it here. For the particle, how do it appear? If the ball moves with that much of velocity UBW with respect to wedge, so what will happen to wedge? Wedge will appear at rest. Am I right? Relative motion. Please do take help of. The wedge is moving. The ball is having velocity. If the ball moves with a velocity UBW, if I project with a velocity UBW, for me, what happened? It appears to be at rest. Okay, there's one very important part. We got the time. Once we know time, okay. Do we know URXS? So altogether now we are able to calculate this particular. These are A, B. Anyway, that is not needed. Okay, let me call this as say some where it will strike. Let it be P. This be P1. Can we calculate X URX into T? So we got the value of X. Can we calculate this H? Because we know T, so we'll calculate the first H, that one. So H should be equal to URY T minus GT square by 2. URY 20, 3, 10 by 2, 3 square.
15.
15, huh? Okay, this is 15 meter. What is X is equal to? X is equal to URX into T.
So
URX is, okay, now we know X, we know H, and this is 45 degrees. Can we calculate also BP1? Tan 45 is equal to PP1 by BP1. So therefore, what should be the value of H by BP1? BP1 should also be equal to 15 meter. Now we know X. Can we get the distance? So AP1 is equal to AB plus BP1. AP1 is what? X. AB is what? Unknown. BP1 is 15. So 30 equal to. Okay, now look at this. What is the overall? Now by this time, so that AB, once you get time, I think we are able to get all the things very systematically. Find the distance of lower edge B of the wedge from point A at the instant the particle strikes the incline. Find the distance AB at the instant the particle was projected from A. So now he's asking the distance when B from the point A at the instant the particle strikes the incline. What do you mean by this? Is asking. I think I should calculate only the initially at what distance it was 15 meter. The instant of striking, where it will be now. So you can see the now the diagram which it is available. So that has to be determined. So how to calculate now? Shall I say B dash will be left of the A? Sir, how do you can see from this diagram? See, that's why I'm telling this one. I need in both the frames, I must have a idea of what actually going on. It'll be easier. Everything you can't depend on mathematics. That's what it may be my methodology. I don't want to depend more on maths because any plus minus sign I may go wrong. That's why I'm taking. So B dash will be on the left side of A. So what is the distance moved by the B in that time we'll calculate. Then we know AB. So can we get this one? So first, what is BB dash? We'll calculate. So BB dash should be equal to U into T. There's a second part of the problem. Distance moved by the point B of the wedge. Okay, this should be equal to U into T. So speed of the wedge, 10 into 3, 30 meter. Initially, what was the distance AB is equal to, and BB dash, what you can write? BB dash should be equal to B dash A plus AB. This is 30, B dash A we don't know, plus AB is what? 15. So B dash A should be equal to 15 meter. Take the path of the particle in the reference frame attached to the wedge. It should be parabolic. In the ground frame, it will be ascending. So this will be path with respect to wedge. This is the path with respect to ground. So that's why I suggest you try to analyze some problems of these kind of where you have to think in both the frames, in accelerating frame or in the moving frame of the wedge. Then this one. These are the answers. Huh? Can be asked in advance. I think within 4 minutes we can crack it. In exams, if you're able to imagine so many things, okay, I think this is not needed in exam. You can imagine this. You have to draw a little bit easy for you to write equations. So draw the very fast rough diagram and get into the concept here. Then writing equations. See, as a teacher, one thing, all of you don't follow teacher. You should have your own method. See, as a teacher, I have to explain, I have to see that everyone will understand. So therefore, I'm writing in detail. So for you in exam, what happened, directly you can write steps and within few lines, what happened, you should end up your own method. You can't just follow blindly the teacher. So forget about the moment you reach exam, you should forget teacher. Who has taught for you? We don't know. What is the name of his teacher? You don't know. How he is? We don't know. Your own method should be there in exam. You can't just follow the sir used to think like this. Okay, I'll think. Not possible. You must have your own thinking. In all sense, you should be independent. You take my only the concepts here, but you should have your own methods of writing equations, solving everything. The physics will remain same. Either you learn or me learn. But the way you utilize it in exam should be according to your methodology should be. These are some two good problems are there where I'm bringing the range conditions. Usually we know if a ball is projected at an angle theta with respect to horizontal, then what is the condition for maximum range? Theta should be equal to 45 degrees. That we all know that one. Okay, let me introduce a different conditions. If there is some wind is blowing due to that acceleration, what can be the maximum range? How to bring that conditions here? Two problems. This one and next problem, the same method is what I'm going to introduce here. Okay, let's have the diagram first. Okay, this is the. So I'm going to throw a ball. There's an acceleration, no? So therefore it will be the trajectory. I'm trying to show a little bit different. Huh? Okay, this should be the trajectory because of horizontal acceleration and also vertical acceleration that is equal to g. This horizontal acceleration is what? G by 3. It is projected with a speed u at an angle theta. At what angle theta? Find the theta for which horizontal range of the ball will be maximum. This range has to be maximum. We know if there is no horizontal acceleration, theta 45 degrees. Now, if because of horizontal acceleration, what can be the maximum range? Hope you are able to understand. Trajectory is justified. Sir, why you are drawing? But in fact, if there is no horizontal acceleration, this r by 2, r by 2. But why I should put in this way? Say t equals 0, t equal to t by 2. Because of in accelerated motion, distance covered in equal intervals of time will increase with the time interval. No? So therefore, I have to show this length more. This is very important. Even trajectory is also very important when there is an horizontal acceleration. If there is no horizontal acceleration, this r by 2, r by 2. This idea. Okay, let's get into the. So what is the time of flight? We'll determine time of flight. So at t equals 0, I project it. After some time t, it is available. The time of flight is independent of horizontal acceleration. So the time of flight is given by t equal to 2u sine theta by g. So horizontal range r is equal to u cos theta t plus ax t square by 2. So this will be 2u sine theta by g. Ax is g by 2 root 3. Let's see what all I'll get it. Square, it is. Two u square by g. I can take it outside. 2u square by g. So this will be sine theta cos theta. So one, okay, that also will get done. So sine square theta. Yeah, fine. So let me differentiate. Let's see, will I get same theta 45 degree or any other thing, that one? Okay, differentiate and equate. Anybody value theta?
60,
How much?
60 degrees.
60 degrees, huh? Okay, pi by 3. Substitute that value. So 2u square by g. Sine 60 root 3 by 2, 1 by 2. Root 3 by 2 whole square by root 3. So 2u square by g. Root 3 by 4. 3 by 4 root 3. So this will be 3 will come. So 1, 4, 4 will come outside. So this will become u square by 2g. 3 plus
Root 3
6 by root 3. Oh, yeah, fine. Okay, this will be u square by root 3 u square by g. Okay, this will be the maximum range. So range will increase or decrease. You check it. Will increase, no, compared to without wind. Remember this condition, very important. So instead of asking numerical, no, if the wind blows, then the maximum range increase or decrease. You may trouble in matchings. You have to be careful. So the maximum range, I think we have so many conditions. Maximum range on incline, up the incline, down the incline, on an oblique. Then again from the tower, even this also find the maximum range. So particle will strike on the ground. Even based on this, we do have problem. No? So all that particular maximum range one, there are 7 conditions are there. All that 7 conditions at a stretch. Analyze them. Anything problem related to that come, you'll be in better position. Here also, what should be the, so what speed I should project at what angle theta so that you can have maximum range from this one, or sorry, it is here, no, from here. Please recollect all this. So will help you a lot in exams. Huh? So I suggest you better have that formulas in hand so that in exam it will be very easy because it may be related to some other concept. So if you know these conditions very well, it will be very easy for you to directly attack the problem, or else first you have to derive, then get into the problem. Means may not be needed, just remember, but advance you should be ready with some basic concept, basic data. So say same idea, little bit some. I have a trolley. Okay, this is the trolley is can move horizontally with a constant speed. Vt, I'll write it. Velocity of trolley, let it be Vt. It'll be easy to distinguish. So let there be a ball. I'll project from here with a velocity ur. At what angle above the horizontal must the gun be aimed to achieve maximum horizontal range? Yes, again, only the speed of the maximum range of a shell fired from a gun is R equal to 22.5 meter. This gun is mounted on a platform. I think there are two different things are there. On ground, when I fire it, this particular, there's a gun. When I fire it, it's going to have maximum range. And this maximum range, I'll call it as RGM or R with respect to ground. So this value is how much it is? 22.5 meter. Okay, this, so now what is this R max? R this should be equal to U square by G. So therefore U, I'll get it as root 25. There's the initial speed. Okay, now I know velocity of trolley. I'm going to project this at an angle. Let me call that as phi. Earlier I used theta, no, let me take that as phi. So now as the trolley is moving, so therefore the speed of the ball will become relative to the trolley. There's a background. So what is the time of flight? Time of flight will be same, 2 UR sine pi by G. Then for the maximum range where? On the ground or on the trolley? When it doesn't mention anything, what we should take with respect to ground. When you project from a moving trolley, what is the maximum range it will attain? That's what our question is. So therefore, let me enter into the problem. First, time of flight. Okay, there's the initial part related to earlier data. Okay, the time of flight is given by 2 equal to UR sine phi by G. Then the range before that, along x-axis, UR cos phi should be equal to velocity of the ball with respect to ground along x-axis minus velocity of trolley with respect to ground along x-axis. Okay, this will be UR. Do we know UR? Okay, we don't know UR. Let it keep. Do we know cos phi? We don't know that also. We know velocity of trolley. So this, we know only velocity of trolley. This I'll write it. Vtx equal to Vbx. Now what is the range? Range should be equal to Vbx into time of flight. And I'll come to this part here. Let me write, I have space. What is Vbx? So UR cos phi plus it is plus Vtx. Time of flight will be 2 UR sine phi by G. Range is equal to 2 UR square sine phi by G plus let me differentiate this dr by d phi equal to 0. Anybody, what shall I write UR? There's a big question mark. What shall I do with UR? We don't know UR, no? The gun,
15.
see, it should be 15 only. See, earlier the gun was on ground. That was absolute velocity. Now on the moving trolley, it will fire. It will fire. It will have the same. So like I think you go back to the muzzle speed. I think I should use word muzzle here. I should use word that muzzle speed. So when the gun is cos phi term,
Expression sin phi cos phi.
okay, one cos phi. Yeah. Okay, now I'll say that this is a muzzle speed of the gun. Since the gun is fixed on the ground, the muzzle will become absolute velocity. Now it is kept on moving trolley. The muzzle speed now what will happen will be UR only. So therefore that UR is what will be 15 only. So what we call muzzle speed it is. When it is on the ground, it will become absolute velocity. When it is on the ground, no, it will become absolute velocity. On moving trolley, it will become relative velocity. Are you able to get this? So muzzle speed, you write it on ground, fixed on the ground. This is, I think, very important. I think now rest, you know, your value all differentiating this. Anybody value phi? I think some quadratic will come.
60 degrees.
60 degree. What is actually here? So it is going to strike on the ground. So what should be the trajectory? The trajectory should be with respect to ground. It should be like this. This is what that range with respect. After this, okay, trolley will be there. I'm not bothered that one. The trolley will be somewhere here. Maybe if it is a long trolley, it will strike on the trolley itself. So I'm not bothered. The trolley will continue to move it. Okay, this is what that range that is being asked. So this has to be maximum. So what is that R? R is this particular thing. This has to be maximized. I think this is very important for army, no? So usually battle tanks. So it's a very fundamental question, not something like a, so in battle tanks or pen, so that particular maximum range can be obtained, not 45 degrees. If the tank is at rest, maximum range 45. When tank is moving, you should bring this particular angle. Very small basic ideas from moving trolley, maximum range is what we have concluded here. Let me construct the diagram. Okay, it's going to be parabolic path. Himself, he has helped us a lot from the diagram. Okay, initially t equals 0. I'll project from here the ball. Okay, there's a ball. When the ball is here, its shadow will be at this particular point. And here is what? A bulb. This is a path of the ball. This is at any time t. and there's a shadow. So we have some information. Okay, no, this is if you can understand question little bit easier. So what is the question now? What we have is find the expression for height h of shadow of the ball on the wall as a function of time. Okay, fine. What we have is the L range we have equation for range. With what speed I should project and at what angle theta I should project. I think this also needed. First, let me calculate the. So what is the condition given? Minimum possible. The ball is thrown from foot of a wall with the minimum possible. There's a most dangerous word which is there in the question. If it is not taken care, I think you'll end up with the wrong way. You may feel you are doing right. Okay, nothing. Because that minimum possible velocity, that word has to be justified. You can project with any speed, but if telling with minimum possible speed, it is projected. Now, what is the condition? It is projected with a minimum speed so that himself he has given trajectory, it will go and strike the bulb. So what is the condition now? With what minimum speed you should project a ball so that it will pass through a point? We have one formula. So I'll make you to recollect. It's a very fundamental one. That should be equal to root of g into under root of x square plus y square plus y. Or what is that x naught? We'll put x naught, y naught. So what is that x naught, y naught? The point through which it will pass through it. So what are x naught, y naught? P is x naught, y naught. X naught, y naught is not point of projection. What is a P? P is this one. P is a point through which the ball will pass. Ball will pass through it, or will pass through it. You write it. Hope you can remember. So please do remember this. We have derived it. So in exam, just before going for advanced or even in mains, no, there can be a question. They may assume that you know this formula. They may ask you in mains. Then derivation, just have an idea how it is obtained. Then you have to remember this condition. Okay, what we know, what is value of y? This is a pointer. I'll call P. I'm projecting with a minimum speed. That is what u. So therefore, I'll calculate this u minimum is what u root of g under root of. This is L square plus 0 square plus 0 square. So this is what that speed. To be frank, when I'm solving this problem for first time, no, I didn't bother. to be frankly, I'm just telling the what mistake I did. That one I didn't bother. Okay, just I went on calculations, everything. That one, okay, velocity of shadow is very simple. What is there in that one? I know this y from this triangle will get it. But this u and theta, what to do with theta, how to eliminate theta. Then I started thinking where how to eliminate this theta. U and theta are unknown. From where to bring this theta. Then I started looking at shadow. Where they any information of shadow? Only we have this information range, but u and theta both are unknown. Okay, then looking back, this once again reading that back question, what happened? Oh, this like this we have to determine. Okay, let's get into the calculation part. Okay, it's very simple. At any instant of time, it will be at a distance x, no? this will be y. So this particular thing is x comma x naught y naught is different here. Okay, let's get into the what is the expression for range. L is equal to other side. Let me come for this one. This L is equal to u square sine 2 theta by g. So this is equal to
Theta
root gl
45.
theta 45. Let me check it. Theta will come how much? 45 degrees. Yeah. So I got this angle, I got this speed has to be calculated. And that's what we did. Now you look at the triangle you have tan theta equal to y by L minus x equal to h by L. I think he's asking expression for h. H is equal to, but we don't know y and x.
So that is tan alpha.
Oh, sorry. Yeah. Thank you. But still, we don't have information of y and x. So I can go back to again y equal to x tan theta 1 minus x by range where this r is equal to L. Theta is angle of projection. We know theta 45 degrees. So substituting this y x, this will be 1 tan 45 1 minus x by L. So therefore y by x is equal to okay, these are equations. I think let me call equation. These are the primary equations. Huh? So yl by L minus x. One more step. Yl by L minus x equal to x. I'll shade it. This is equation 1. This is equation 2. From 1 and 2, what happen? I get h equal to x. Is asking h as a function of time. So now I know what is x. X equal to u cos theta into t. U is what? Root gl cos theta. So finally, h is equal to root gl by 2 into t. This is our answer. Many ideas he has just mixed up here. Many ideas. In one single problem only, he has just dumped many things. So there's one best formula, what we know. Our angle of projection coordinates are related. There's a one thing. There's a one more formula. So please remember me. Let me take next one. Uh, just a general, how do you rate this online classes? What is the efficiency compared to offline classes? Anybody? For scale of 10, okay, you do one thing. Just I'm doing survey. What all you feel, no, you can write on paper and just post it in WhatsApp. Send it to me. Some are saying same as offline, sir, everything, because I think this is a very important, you can say, the breakthrough in the education system. What all we have this online coaching now, the way we are building up, no. Already the American universities, they have made the campus into two parts, offline and online. Anybody interested through online, they need not to come to the campus for all academic year. Online only will be provided for them in future also. American universities accepted it, and they're bringing all the technologies, still the better technologies for this. It can be a revolution. You better say like it's a revolution as begun. The advantage of this is the physical classes, the building cost is very high. So year open, the cost will come down like anything. The education will become very cheap using this online. It can be affordable by anyone. Anyone, maybe like it will become universal. High quality education can be made available to anyone. So that's what the impact of this online. Huh? Maybe those who are well settled in, those who are well settled in offline business, no, okay, they may feel threatened, but online what happened is really good for society. That's what many parents also just call me, like those who are very poor, no, for them it's good, no, they need to pay lakhs of fees, because for online you need not to charge so much of fees. No question of building, nothing is needed. The American universities have slashed their prices by 60% their fees, because for online they have brought it. It's a huge impact for society, or better you can say that no question of band, nothing. See, practical labs we have to be offline. That's another thing. But it comes when it comes online teaching, no, it's a remote places. What happens somehow if you can bring the internet connection? How to get internet connection? I think the another 5 years, even the remotest village is going to have the internet connection, no doubt. In America, what happened? In America also, the people suffered. What government did is like the mobile towers makes like a small, like a mobile station, like a, you can say like a transmitting station. It was fitted on the buses, and that particular bus, what happened is placed at during in that village, and the village, what happened, they used to get that internet access. Same thing, like suppose if we have like a BSNL, Airtel, so many companies are Zero, that one. So what they brought is like a transmitting stations, that one. That particular transmitting stations was fitted in the buses, very small. It's a very less expenditure also. They have made that buses to be there in that village, and the village used to give good network. The Western countries, the connectivity to the village, what happened, they have made successful by using this method. So in the village people, what happened, due to poor connectivity, nobody missed any online class. But in India, I think the total poor has lost the education system completely. Till date, no, if you go for some villages, no, 2G network not possible online. Lag will be there, not possible. So these are the things are there. The what you can say like a mobile transmitting stations which are implemented on the bus, and that particular bus was stationed in that particular village. The technology is taking, you can say, a better shape with respect, after, you can say, after 300 years there's a change in the education system. 300 years, almost from 16th century, this particular system is brought into picture, no, almost you can say after 400 years we are noticing a change. Okay, let's there's a very simple question. I don't want to write any equation. Okay, let me draw that box. It's not a big thing. Think very smart. Easily you'll end up this particular question. No need to write lengthy equations like earlier problems what we did. Okay, there's a train. No. No need of diagram also. Those who are unable to imagine is what I brought it. So it will enter that the train will continue its uniform velocity motion. It will continue its uniform velocity motion. Okay, now you see this. There's a velocity. V it is given. Okay, let it be small letter. Here is a hole. A railway compartment. It moving urgent with speed u perpendicular to the a particle moving urgent with speed u perpendicular to the direction of v. So it will enter along. So if you write coordinate system also, if you want, you can take it. Otherwise, not needed actually. Okay, if you take this is x-axis, y-axis, this is z-axis. Now you see this. So the ball will enter perpendicular to the sun. Along z-axis, it will enter here. It will enter, there's a hole. I think you have everything. So where it has to strike opposite corner B. The G will act here like this. Possible. Where it has entered will be there only. Oh, I think I should bring below. This is below. I have to bring it. This one. Yeah, this is what the okay. It should be the condition should be like this. Okay, now I think we are in better position. This is z-axis. This is a point B. It has to come and strike this particular the ball. Definitely the hole will go. No, what makes it to along? It is having only velocity along z-axis. Am I right? So shall we calculate first the time taken? Let me take this is h. Physics for me very easy online than offline, because in offline we have to write question on the board. Here open data, I'll bring question, I can discuss the concept. Especially the revision, I feel like this will be very good because directly we can bring questions, we can speed up the things. But in offline, what happened on the board, what happened there, writing questions, discussing that, it was a little bit difficult. Visualizations can be brought, but the way the coaching industries may not permit us to do anything, because we have to do so many numericals so that you get exposure to different types of numericals. Then something related to that will come in exam, you'll get a better rank. So I can bring graphics all, but everyone feels that that may not help much in exam. Waste of time. So therefore I'm avoiding it. Okay, now time. I think we know h equal to 3.2 meter. You can see this. 2 into 3.2 by 10. 8 seconds.
0.8.
0.8. Okay, I have some time. He's asking what is the velocity of train and what is the speed which the ball will enter. I think so many questions that are being asked. What to do after this?
Equating distances.
Yeah, that's all. No? So what is the distance moved by the B? It will move a distance of how much? 16 meter. So that 16 meter V equal to 16 meter into T. What is the speed of the ball? Speed of the ball along
Vt is equal to 16, sir.
V equal to 16 by T, and the speed of the ball will be 2.4 by T. Problem over. Okay, I'll get V. V will be
20.
20. Yeah. U 3 meter. Oh, yeah, fine. Now there's about V and U we can pick up. To an observer inside the component, the path of the particle is parabola. What you first will talk about the person on the ground. Person on the ground, how do it appear for him? Path of particle with respect to ground. Path of particle with respect to compartment, railway or there's a train. Huh? Okay, we should analyze that also, no? It should be parabola.
Both parabola.
And what about the with respect to train? Should be parabola,
Parabola.
there also. Is telling no, it it will enter into all. So for it to enter into all, so definitely there should not be any y component of velocity for the ball when it's entering the all. I think that condition has to be assumed here. Because for it to enter into the hole, so definitely should have only velocity along z axis. Am I right? I think then only we can manage this question. I think we should think in that way only. Better to say, sir, y has sir any y component of velocity, then it cannot enter into the hole, no? Okay, now we'll take the next one. Okay, there's a minimum separation. Some small condition is what being introduced here. Two points are there. Two rocks. Okay, there's a one rock, red color, another one. I'm going to launch it so that simultaneously, so they're distance apart. Okay, there's all information, what all we have. First we'll write it. Then with equal speeds. At different angles. So theta 1, theta 2. Each rock lands at launch point, knowing that one rock is launched at an angle theta with horizontal. What is the minimum distance between the rocks during the flight is telling. So what is the trajectory? Trajectory of this will be, we'll take like this. Different angle himself is telling. So this will be the I'm trying to give first diagram, so it'll be easy for us to. May not be exact. I think all of you will agree. May not be exact. What is the minimum separation between them? Since the angles are different, so they must have a different maximum height. Possible, first of all.
Yes, sir.
Yes, sir.
Yeah, it can be possible. Can we get the other angle?
50 the range.
The range should be same, no? Complementary angle. So the theta 1, if it is 37. I made that one more, no? Theta 1, if I assume 57. Okay, I think let's not bother. Okay, how to get that minimum separation? Can we calculate the speed also? Speed of projection?
Yes, sir.
Okay, we know range, no? So this range should be equal to, let me first get this. This range should be equal to 2u, or anybody value u?
Sir, u square equal to 1250 root 2 by 12.
1250 by root 2, huh?
1250 by 12 into root 2. Root 2 in numerator.
Here, huh?
Yes, sir.
1250 root 2 by 12. I think we can simplify further. Just take calculator and give the value. Okay, it'll have some, we'll do it. I'll proceed here. So now let me get into the minimum separation one. Okay, there's a background is what I had. I'll make diagram a little bit small. Okay, there's a minimum. So in fact, I'm going to project, let me call this a ball A, VA, theta 1. $12.136. 14, I'll write it. Okay, there's a VA, and VA equal to VB equal to U. That we know it. Then we know this separation D. So what we do is like, let me keep this A at rest, then let B move with a velocity VBA. So it'll become very easy for us to
No need of velocity now, sir.
I too don't know. Like I'm just calculating what all information, just gathering the information. I too don't know that one. So let A be at rest. Then what happened? The BA will move. And there's a very popular, I think everyone knows that there's the approach. Then when do it happen? When B moves with a velocity VBA. What is the direction this? We don't know theta. Okay, this is, I think usually this is A, B. Let me call this is M. This is what that minimum distance. Somehow we should calculate this theta. And we can also calculate the time taken at t equals 0 here. At what time the minimum, at the time at which the separation between them will be minimum. So for that, we'll go for VBA equal to VB bar minus VA bar. Okay, VB, so this should be equal to U cos theta 2 I cap u sine theta 2 j cap minus u cos theta 1 I cap plus u sine theta 1 j cap. Cos theta minus of u cos theta 1 I cap. This will be u sine theta 2 minus sine theta 1 j cap. Call this is everything vbx vbx bar plus vba y bar. Okay, look at the triangle, how the triangle will be. Minus vbax this will be vbay positive, no, it is. This is vbay and this is vbx and this is what vb and this is theta. So what is tan theta? Tan theta or tan phi, I'll write it. Tan phi will be vba y by vbx. So this will become sine theta okay, I'll get the tan phi. After getting the tan phi, the value of that minimum distance 2 meter. Okay, there. So now next I'll go for sine theta sine phi is equal to S minimum by D. Anybody tan phi value?
1 by 7.
1 by 7, huh? No. Tan inverse of 1 by 7.
Yes, sir. Tan inverse of 1 by 7.
Okay, now you can calculate the sine phi, substitute, you'll get the minimum that one. Then also you can calculate the time taken. For the time taken, what is it needed? So we know VBA, the magnitude. So then what is it? This should be equal to the distance BM should be equal to VBA into that T. So this is what the time taken when the separation is between them is minimum. VBA is root of VBX square plus VBAY. Only thing is somehow that initial things that have to be taken care properly. The rest all you know, keep one as at rest, other thing that one. Or else what you should do, you take this as origin, then define the coordinates somewhere at this particular point, then you should define this one, then you should differentiate equal to 0. It will be very, very, very lengthy. It will be very, very lengthy. So always the best approach is what the books have given. We can also do one thing. At any instant of time, I'll find out the separation between them. It'll be very lengthy after this one. There'll be. So what is that minimum as it is proceeding like this, and it is here, no? So that minimum separation can be somewhere here. For your understanding purpose, I'll just give a diagram. What we are finding out, no, that can be minimum separation here. Just for our convenient purpose, may not be exact, sir. Here only how you can say I too don't know. Just this one. So this will be ascending. This will be moving. So here the separation will become minimum. This is what we are finding out by this method. But sir, here you have shown like this. But here it is like a motion of B with respect to A. Things will come on the ground. Okay, you see this one. Somewhere the separation between them will be minimum. Getting the condition, this will be. This, okay, we can do this one, very simple. A very useful problem. Block, I'll show a little bit. Only this one, you need not to. Okay, there's a block. This is very important for us also when we are crossing the road. Very, very, very important. We should, how to cross the road is something when vehicle is approaching. Okay, this is moving with a constant speed, u. The person, the ant is telling. So the ant is somewhere here. The top view is what I'm showing the diagram. What given is like a 3-dimensional diagram. So let's make plane diagram. It'll be easier. So initially it is this one at t equals 0. This is here. This is a thing. Okay, now what is asking? Find the least value of v for which the insect can cross to the other side without getting it by the block. It begins to crawl at a constant velocity v. So at t equals 0, it starts crossing. So shall it crawl like this? If it crawls like this, what is the problem? Least velocity. It begins to crawl at a constant velocity v at the instant one. So find the least value of v. If it crawls like this, definitely it is going to hit the block. If it crawls like this, there's a possibility. So since the velocity is least, no, it has to crawl like this. Maximum velocity it can crawl. Am I right? I think it's there in icon. Most of the books, their person, a truck is approaching the width of the truck they given. Then what should be the minimum velocity of person to cross the road and in what direction? That was the thing. So here what happens, since the velocity is minimum, no, if ant moves like this, it will get crushed by the block. Even this also possible. Since it's a minimum, so the path should be like this here. So by the time the ant reaches here, so where the block is just will cross that particular edge. Okay, the ant will be here. So what about the block? Block is going to it can happen, no? This was the diagram which is being asked is of this kind. Okay, now get into the mathematical part. So the ant what happened should crawl with a speed v, that speed should be minimized. So we know this length is L. What is the time taken to cross the road? So component of velocity, I'll put it. So this is t equals 0. This is t equal to t. Put it like this here. So now the time taken to cross should be equal to L by v cos theta. Okay, see further what you can do it now. How much of distance the block will so this distance should be equal to, shall we write say x, so that should be equal to so what is the distance crawled by the ant along x-axis? This is along y-axis. Along x-axis, x should be equal to v sine theta into t. What is tan theta? Tan theta will be x by L. So that x, I can write it as L tan theta. I think same thing will end up. The above equation T equal to L by V cos theta, what is there? The same thing will end up. Okay, let me just have that in the end. What is the distance moved by the block till this one, D plus X, and what is S is equal to U into T, and X is V sin theta into T. So we have to get that expression for T. I should eliminate, no? U is equal to D by T plus V sin theta. Okay, T, I'll write it as dV cos theta L plus V sin theta. V is equal to, now it will be UL by okay, now I'll differentiate dV by d theta so that I'll get an angle. Anybody value?
is equal to UL by root of L square plus B square.
V minimum, huh?
Yes, sir.
V minimum is equal to how much it is? UL by root of
L square plus B.
L square plus D square. Huh? Theta, any?
Tan theta equal to D by L.
D by L, huh?
Yes, sir.
Only this much. Huh? Yeah. So that particular thing, what happened, the angle at which it so it has to be at this particular angle. If it moves, then the speed should be this much. Then the ant what happens successfully it can avoid being crushed by the block. I think the same thing, person walking is there, that one. Minimum speed, okay, it has to be like this. Maximum speed, you can take a risk like this. You can go like this if you have a maximum speed. Any other questions can be asked here? So just a very basic fundamental one. Tomorrow, what to do with the class? Shall I take that in the afternoon or evening? Because morning may not be. What do you suggest, like tomorrow's class timings? Shall we keep it in the afternoon or evening? I'll mention the timings, no? Then, okay, first we'll end up the class. Thank you, all of you. Yeah.